Hello friends, welcome to BISP Solutions. Myself Ashwin and I work as a technical consultant at BISP Solutions. And this is our another bootcamp session on Perceptron. Today we are going to see Perceptron and neural network. Now what is this Perceptron and neural network, right? Let me explain you first. See, in our last sessions we have seen the linear the regression, right, where we have to find out the series of the predictions, right? Prediction in the series. Now here we are using Perceptron. Now Perceptron is a technique of prediction where the answer could be either yes or no, right? For example, let me give you an example first. Let's take a daily life example. For example, I have the data of the IIT pass out students in 80s decade, 90s decade and 2001 to 2010, that means 2000 decade. So I am having the data of these IIT pass out students in 80s decade. Suppose let's take 5000 students were passed out, and out of that 4000 students they moved to abroad. Similarly, in 90s decade, let's take an example, 7000 students passed out from IIT colleges, and then out of which 6000 moved to abroad. Similarly, in the third decade. Now based on this data, I am having the data currently, that is 2022 till today. Now based on the previous history of the IIT students, we have to predict that how many of these so far passed out, that means from 2020 to 2025, how many students will move to abroad based on the, now this is a prediction based on the previous history. Now there could be many there could be many criteria, right? Now in this criteria, for example, the background of the students, in which school the student passed, in what session, in what how many percentage the student gained. So based on this criteria we do the predictions. So that is why here, if you see in this image, Perceptron is a type of artificial neural network. It is primarily used for binary classification, either yes or no. Now let me give you some just a brief introduction. A perceptron is a type of artificial neuron that mimics how biological neuron in the brain works, right? Just like how our brain processes information, a perceptron takes data and processes it and produces an output. That's it. For example, if you see in the, if a person, if he sees that a particular city or a particular colleges produces large maximum number of good IIT students, IITians, so definitely based on that data the person will select the college for his own child, right? So this is all about the person's decision, human brain. But how the perceptron does this work, that we are going to see in this our today's session, right? So perceptron mimics the activity, or what we say, the how the brain works. It mimics that particular activity by perceptron, right? It's an artificial neuron. Okay, so now let's see this. Perceptron is a type of artificial neural network. It is primarily used for binary classification. Binary classification, now see here, as in the beginning of this session I have shown you, there are, suppose I have the 80s decade IIT students history, 90s decade history. Same thing is here. Look at this: x1 w1, x2 w2, y x3 w3. These are, consider this as are the historical data. Based on this, whatever the neuron perform the operation, and then it gives you the output. Now see here, same thing, what does a perceptron works. So now look at this, x1 w1. Now here it is given x is an independent variable. Since last 3 sessions we have been looking that we keep independent variables in the x variable and dependent variable in the y variable, right? Same thing is here. X means independent variable, W means weight, the coefficient or the additional information. These are the inputs. B means bias, the intercept. Then activation function. Activation function is a function in which we extract the data, and y equal to, this is the formula f, that is the activation function, bracket w dot x, w means the weight, dot x means whatever the independent variable, plus b, b means the bias. So this is how it works. Now look at this. Okay, now look at this, right? What we are going to cover in this module, we are going to cover a standard Pytorch workflow. Okay, that's fine. Here we are talking about the Perceptron. Now Perceptron, we are using the term Perceptron, but almost the technique is relatively same, right? First of all, we will get the data, then we will build a pre-trained model, then pick a loss function and optimizer, build a training loop, and then finally again it is sent, then fit the model, right? Then fit the model, fit the data into the model, evaluate that model and improve through experimentation, that is the epochs. Today again we are going to see, right? I will show you again and again so that you will memorize that exactly how the process is going on, and then ultimately save and reload your trained model. That's it. Same thing in our last previous session we have discussed. A student, he reads each and every book, right? But in the exam test, hardly 20% of that course is asked and checked that whether whatever the student has learned. So everything will be clear. Same thing here, train model, how it runs. It takes first inputs, then it convert it into the tensors. Then here tensors are loss functions. The loss, with help of loss function, loss is calculated. After that the feedback, back propagation feedback is given, and repetitively it is working, and then finally the output is generated. Here is the optimizer, it also plays an important role to optimize the data. Okay, so this was all about the theoretical part. Now let me show you the practical part. Here look at this. For Perceptron I have already created this, but I will show you once more time today, right? Okay, now first of all I will create a fresh IPynup file, right? Just a second, just give me a second. Okay, so let's start again. Yeah, now see here what I'm doing. I'm creating a new file, Python IPynup, right? Perceptron demo on loan data. Let's take it Perceptron demo underscore loan data. What is this loan data? It will be clear. Perceptron demo loan data. Yes. Now see here, Perceptron demo on loan data means we are having some historical data of loan. So first of all, let me do some steps and then I will explain you, right? Let me perform some steps, then I will be easily explain you. So here first of all import torch. Torch means it's a big library, and then torch.nn. nn is a library in itself. In this each and every function and property is given, so that is why we are using this torch.nn. Then torch.optim, that is for optimization, right? Then let me make it enter. Now as scikit-learn data sets, import make classifications, then train test split. We are using train test split. After that, standard scalar. Then we will use matplotlib for plotting the data, numpy for mathematical calculation on data, pandas for cleaning and massaging the data. Pandas is a very popular library which is used almost for every what we say cleaning, massaging the data, right? So now let's wait for 2 seconds. I will explain you about the sheet also, Excel sheet, right? Just give me 1 minute. I am now reading the data. Okay, now see here we are having the historical data of a company, right? Of a company, we are having historical data in which all the historical data of the client, the employees are given, but we have not taken the name of those employees, right? Gender, for example, gender, person education, that is master's degree, person income is this, and person home ownership, either rented or owned, then loan amount, whatever the loan amount it has given. And here you can see just a second. Yes, here you can see the loan status 0 and 1. That means bank will provide loan or not, right? Yes or no. So this is the complete data of the historical data of a company, right? Now based on this, in future, suppose if any person comes and he matches any one of these criteria, for example, he is from rented category, then he wants a personal loan, then his person incomes might be near about this 71948, right? Then if he is a master's, so any of these criteria will match to that person, and based on that our what we say, the Pytorch Perceptron will determine that whether he will get the loan, yes or no, or he is eligible for that loan, yes or no, right? So now let's wait just a second. Okay, now we are going to now see here. First of all, we have imported the data, right? There are 44,000 rows. Look at this, 44999, almost 45,000. Now we have imported the data into the data frame, right? Here is data pd.read.csv. that means it's a data means data frame, right? pd.read.csv, whatever comes in this, it is called as data set. Now in this data frame, look at this. So this is a alphabetical value also. You can see here the bachelor, the high school, and the main thing is that the Perceptron does not work on alphabetical value or neither the alphanumeric value. So what we need to convert all these numerical alphabetical values to the numerical value. For example, if data person gender dot map male equal to 0, 1 and female equal to 0, that means wherever the male is there, it will be changed with zeros and ones. Data person education, again the data person education dot map and associate with 0, bachelor with 1, master with 2, doctorate with 3. Similarly, person home ownership, whether he is rental or other or own or mortgage. Similarly, all we will do, we will change each and every word into numerical value. Okay, and now what happens here? Data. Suppose if I put here data, now see, you will not see any type of alphabetic value. Okay, now our first target is to convert each and everything into the zeros and ones, and this value is taken in while calculating in the Perceptron calculation, right? So here you can see we have converted each and everything into the numerical value. And now what we have done, now see, the procedure is almost the same. What is that? First of all, taking the data and then removing the alphabetical value from that particular data. After that, dividing the data into two variables. One is the independent variable and another is dependent variable, right? In my last video also I have explained you that dependent and independent variable. Now again I am clearing this concept that what is independent and what is dependent variable. Suppose if I want to open a cold drink plant, so cold drink plant profit is my dependent variable. How this plant will get profit? Now based on so many criteria, so many parameters. For example, what was the summer season highest temperature list within highest temperature record within the last 5 years. So based on that and based on the prediction done by the weather department, these are our independent variables. Based on this we identify or we take the decision, okay, we should open one cold drink plant there also and our sales will be very high. And suppose if a city where the historical data is like if you talk about our metro, there are few cities in which even in summer season also people don't feel like summer. The temperature does not go beyond 30-35. So in that case the company takes decision, right? So based on the historical data, so that data is called the independent data, and the data profit, what actions we are going to take, that is called the dependent variable. Clear? Same thing is here also. Now here in this table we are having the historical data. Now this historical data, the independent variable is loan status. Either he will get the loan or he will not get the loan, or he is eligible for loan or not. Similarly, let me give you one more example. If a builder is trying to open a shopping mall in a city, so what are different parameters based on that? Number one is the spending capacity of the citizens in that city. Number two is the how many engineering colleges are there, how many coaching classes are there for engineering. Number four, how many companies, IT companies are there. In that case, if a builder or if a businessman opens the shopping mall there is a chance of profit. So profit is directly proportional to so many parameters, and those parameters are called dependent variable. And same thing, dependent variable means we are putting it into X, Y means dependent variable, and both on this we will apply the perceptron code, and then that perceptron will calculate. Suppose now if I put here X, look at this, and similarly Y, right? Now if I show you the shape, look at this shape. 45,000 is the shape, right? 13 columns. Here you can see here the 13 columns of X variable, and 45 is the row, 45,000 is the row. Similarly in Y shape means one is the column you see in the right side of the comma, and 45,000 means the rows of the particular X and Y variable, right? Now what we are going to do here, X train test. Now again X train test variable, X train, X test, Y train, Y test. This is the function X train, X test. And now this time we are going to take 30% for testing and remaining 70% for training. Okay, random status 42 means each time the data should not shuffle. every time it changes, then how will we calculate? Okay, now here if you see, first of all we have taken the data, then we have converted the alphabetic value into numerical, then we converted that data into the X10 test. Clear? Now standardize the data. Now see, now once the data is converted into the here train test, then we will put here in the standardized format. So scalar equal to standard scalar, and then X10 equal to scalar dot fit transform. So we have to fit the data and transform the data, right? So now if I show you here, look at this. Now see here, X10 X test is done. Now once X10 X test is done, then we have to convert that into torch tensor. Here we need to see here, look at this, X10 tensor equal to torch dot tensor, and remaining X10 Y10, similarly Y test tensor, X test tensor, Y test tensor, right? So converting them into the tensors. After converting them into tensors, what will happen? Just a second. Yes, okay, what will happen? Now it is ready to work, right? Now it is ready to work. So our next step is this. Now look at this. Actually this is a Perceptron class. It's a function in which we are going to put the data, and here the activation function is sigmoid. Now do you remember that initially we have taken torch.nn, right? Let me show you this torch.nn here. Same, this nn is here, right? The nn function is used here. After that, here the sigmoid function is used. So what is sigmoid? We will understand this in our upcoming videos. So right now this is just a function, right? After that, forward activation function, okay fine, return x. Now after that, what will happen? So if I put here input underscore dim 13, why 13? Because 13 are the row, sorry, column. 13 is the column. So whatever the shape X10, that is the column, it is showing the number of columns. Okay, then now you can see here in this function, initialize model, loss and optimizer. So we have to do the modeling part, right? So what happened here? Model equal to Perceptron input data, okay fine. Criteria is nn dot BSC loss. Now here we have used, previously we were using what previously we were using? We were using previously MSE loss. Look at this, we were doing mean loss error. Previously we were doing mean loss error, right? Let me write down here binary clause. We were doing mean loss error. Here we are using binary binary cross entropy loss, right? Binary cross entropy loss. Now after doing this, here you can see optimizer function has run, optimizer function has been executed. Now you can see here, now if you see here, now we have to calculate the loss. We have done the optimizer. If I show you the PPT, look at this. Here it is written loss function. So that is why we have to do here, optimizer is written. Now build the training loop. Same thing we are doing. First of all, loss is calculated. Now with the help of this, we have to run the epochs 1000 times, and then the optimizer starts here, right? And after that, here you can see enter. Okay, now look at this. So many times this epochs is running, right? Look at this. Now it is over, right? 1000 times the loop runs. Now see here, epoch plus 1 slash number of epochs comma loss, right? So loss is also calculated here, and in this way epoch has given the information. After that, okay, now if you see here, epochs is running. Now after epochs running, you will see step 5, that is the evaluation model. We are going to evaluate here. Look at this. We are evaluating means torch.no gradient and y class prediction, y prediction and y prediction class, right? Now we have calculated our y prediction class and applied y, and it now accuracy comes here 88%. That means the accuracy of our Excel sheet is given 88%. So our system has given you the information that 88% accuracy will be there. Now what we have done here, let me show you. Now this accuracy is done. Now we have taken a new data. Now we have taken everything just like Excel sheet, right? So in Excel sheet also we have used 0 and 1 for male and female, right? Same thing we have used here. That means this is the actual data of a person where everything is there, like body mass index, and if I show you this first, look at this. The age, the credit score, each and everything. Now based on that we have executed the data, right? So based on that we have executed the data. Then what will happen? It has given you predicted class, that is one loan status, that means the bank will provide him the loan, and predicted probability is 0.90, and in this way we have proved it. Now second thing, after this what we are going to do? What happened here? PCA, apply PCA to reduce features. So PCA means principal component analysis, right? So apply PCA to reduce features to 2D for visualization. So PCA equal to PCA n components, n underscore components, and then equal to 2. After that, that means n components equal to 2. That means all the for all the components 2 is assigned, right? Now here extend PCA Now PCA dot fit transform, again that fit and transform and fit data, right? So extend PCA equal to PCA dot fit transform, right? So X test PCA dot transform X test, extend and X test both. Just a second, please hold on. Now see here what I have done here. We have taken here plot decision boundary. Now plot decision boundary means exactly what? Now here we have, this is a standard formula, we don't need to make any changes, we don't need to temper this code. At the end of this formula you can see here X train PCA data type D type and then plot decision boundary, right? So if I hit the enter button, right now it is working, and as soon as it will show, we will check it out. So what we have done here, plot decision boundary, and here we have taken the X train PCA. Okay, so we need to wait for 2 seconds. Now look at this, it is converted, your data has been converted into this chart, right? So you can see here decision boundary PCA reduced space, right? And then here PCA component. So it has converted your data into this value, right? So this is how the Perceptron works. Now Perceptron, let me show you once again the quick recap. Let's have a quick recap first. First of all, what we need to do, these are some important and very necessary libraries, right? So these things should be pulled. sklearn, what is this sklearn address, what is the database, then what is the pre-processing, right? So these all things are captured here. After that, what we will do here, matplotlib, pandas, each and everything. Then we will import the data. Now importing the data is a different task. Importing the data, and then we will first remove all the alphabetical values from here, and then it will be converted into something like this. Then again train test means x and y. X and y means x is the independent variable, y is the dependent variable, right? Then converted both. Then print x dot shape. Shape means the same, the row and the column, right? The row count and the column count. Then x train test. Now the train test model immediately comes. Train test, it splits the data into train and test, and immediately they have to provide it into x train test. Okay, then what we have done, the standardized scalar x train x test, right? Scalar dot fit dot transform, then scalar dot fit scalar dot transform. Now what will be the next? Convert to Pytorch tensors. Convert to tensors, Pytorch tensors. Now see here, we have converted into Pytorch tensors. After that, Perceptron function comes. Perceptron function is a standard function. We have to just pass the parameters, and then at the end here nn dot sigmoid is used. Sigmoid, right? During the session, in this sigmoid is used. After that, input dimension x train shape, and then input dimension, you can see here the 13 is the column number, right? Number of columns. Now initialize model, loss and optimizer, same thing. So what we initialize, nl.bse loss, right? So binary cross entropy loss. For classification, we were previously doing mean loss error. Now optimizer equal to opting.sigmoid and model.parameters, right? After that, model Perceptron is used here. Look at this. Define loss and optimizer, and then Perceptron is used. Then we apply the epochs. Epochs means it's a kind of repetition, right? So we call it as epochs here. Now in this epochs, we have defined that 1000 times you have to execute. After that, look at this. Once we print this, right, then the epochs is showing the values. Then later on, look at this, Pytorch no gradient. So evaluating the model. So we are evaluating. So yprid equal to model x test tensor and then yprid class. So yprid greater than 0.5 and then accuracy is this. After that, accuracy is on test data is 88%. Now in this 88%, it has shown us the test data accuracy. Now next step is predict on the new data. So predict on the new data means we have to just take the values for new data and then we have to apply this. After that, here you can see the torch dot no gradient, and then you will see here this is the data, the prediction probability that is 0.90 and then predicted class that is 1 and loan status is yes. That means the company or the bank will provide him the loan. This is what our target was. For sklearn decomposition PCA we are using principal component analysis, right? So principal component analysis. So we have calculated this also and then plot the decision boundary. So in this decision boundary you have to just pass the data here only in the last 3 lines. Okay. Now in this way we have plotted the data. So guys, this was all about the Perceptron, where Perceptron is used where only one either yes or no data is that matters, right? Either yes or no. Same thing is here. Okay, either yes or no. Now in this way we have taken here. Now Perceptron is also 2 types, right? Single and multiple. So this is a single layer Perceptron. In our next upcoming video we are going to see the multiple layer Perceptron, right? So guys, I recommend you to watch this video twice, thrice, because without practice it's very difficult to understand that machine learning language, right? So you have to do the practice on this. Clear? And in our next bootcamp session we will see multiple layer Perceptron, right? And those who are new to this channel, please subscribe my channel here, right, so that you will get the notification. Okay guys, see you in our next bootcamp session. Thank you, thanks for attending the session.